So 3 years ago, I built this really cool mobile flip-top workbench. It was shared by Wen Tools. It was featured on the Family Handyman, and I posted a few videos on YouTube years ago just to share it out with them. Nothing really came of it, and within the last few months, it got a lot of attention. And with that, there were some questions about how the ins and the outs of the bench worked. Unfortunately, I did not record a build video when I made the bench initially. I did take a lot of pictures, however, so with this, I want to explain how the current bench operates, go through some of the pictures that I do have, and explain the rest using 3D renders of how the ins and outs of the bench work. All right, with all that said, let's get started. First, I want to go over some of the features that I needed this bench to have when I was designing it. When designing this bench, there were 6 key features that I wanted the bench to have. First off, I needed the bench to be mobile, but only sometimes. Where I'd be storing it was not a very functional space, so I'd need to be able to move it out into the open easily during use and then able to move it back so I could park my car in the garage in the winter. Once placed, I wanted it to be sturdy and not shift or move on me, which can happen on casters even when they're locked. A mobile bench is not a new concept by any means, but to my knowledge, the way that I chose to do it was. Second, I wanted to have multiple tools built into the workbench that I could use quickly when needed and tucked away when not in use. This would not only be a huge space saver, it would also make the tools quicker to access and more stable once in place. Again, a flip top is not a unique feature to a workbench. However, the way I chose to do it was, and I'll explain that reasoning later on in the video. I needed plenty of storage in this bench. All of the tools have accessories that go with them. Most of them I don't use very often, and a few of them don't stay in place well when the tool is stored upside down, so I needed a place to store them. I also wanted this bench to be used as an assembly table. The one drawback to the way I made the flip-top function, which surrounds the entire bench, is that it doesn't allow for any overhang for clamping, so I needed to find another way to clamp a project securely during assembly. I wanted to have some sort of paper stored in the workbench to make it easy to protect the top of the bench during glue-ups and finishing. This was a quick, easy solution that kept it clean and convenient to ensure that I would actually use it. Finally, the bench needed to be just below the height of my table saw so I could use it for an outfeed table. My wife was also getting sick of having to hold sheets of plywood as they came off the back of the table saw, so this made her happy as well. So let's start off by talking about why I made this bench and why it might be beneficial to you when you go to design your next bench as well. Like a lot of people, I use my garage as my shop. So space is obviously a big deal to me, as is mobility, and because the place that I store my tools is not where I plan to use them, I needed to have certain features in them so I can move them around. I do live in the northern part of the US, so I have to be able to park my vehicles in the garage come winter. I have a 2-car garage, but mine's a little different than most. A lot of 2-car garages tend to range from the large end being around 24 by 24, giving you just over 300 square feet of functional floor space with the cars pulled in, to the small end being closer to 20 by 20 with only about 128 square feet, which is going to give you very little storage space. Mine's a little bit different because it's actually right around 19 by 22, meaning I have next to no space on the sides. However, I have this extra space in the back that's an extra 7 by 9, which gives me just over 200 square feet. That extra space is extremely important from a storage aspect because I can store almost nothing on the sides in order to allow the car doors to fully open, so I had to get really creative. When we bought the house, I had planned on this space being my main work area. I built a workbench back there and loved it. However, it didn't take long for me to realize that the space wasn't very functional with any larger project. I found myself cutting things down and assembling things on the floor out in the main part of the garage, which defeated the entire purpose of even having a workbench. That space is great for storage, but it wasn't big enough to be a functional work area. So I spent months saving to buy all the tools and planning this thing out, researching and figuring out how I wanted to make it mobile, how I wanted the flip top to work, and other features I wanted to include with it. So once I had the final approval on a layout from one of my furry friends, it was time to get started on this thing. One of the main questions I get is about how the lift mechanism works in the bench. It's actually a really simple concept. So let's go over how and why it works, and then I'll go over how to make it. When you pull this lever, it rotates 3 cams secured to a steel pipe running the length of the bench. When these rotate, they drop 6 casters onto the ground, which then forces the bench up into the air. The secret to the cam is an offset hole. As you can see here, if you have a wheel with a hole placed in the exact center, the distance at the bottom never changes as the wheel rotates. Therefore, this could spin forever and not do anything. Now let's drop the hole a ½ inch off center, and you can see that you now have a full inch difference between the top and the bottom. Because of this, as the cam spins, the distance between the steel pipe and the board increases, which is why it forces the board down. So then why does the bench lift when this happens? The steel pipe is mounted in 3 cross beams within the bench, only 2 of which are pictured here. Then, as the casters are lowered and forced into the ground, they eventually have nowhere else to go. So all that force then pushes the steel pipe up, which then forces the entire bench to raise up off the ground. There are quite a few reasons I designed it this way over other systems that I had seen. First, it would always allow the bench to be on its frame other than when I needed to move it. This made the bench sturdier and less likely to move on me when in use. Second, I didn't want to have to walk around and lock 6 casters one at a time. Not only is this system faster, it's also more sturdy than locking casters would be. Third, I didn't want any kind of large mechanism that stuck out or that took up more floor space that I could trip over. I've seen others that use a lever you pull down, which sticks out pretty far, and also takes up a ton of space in the bottom of the bench, and I didn't want to lose that room. And finally, it turns out this setup is still really strong, as my bench weighs over a ½ ton, coming in a little over 1,000 pounds on its own when you include all the wood and the tools that are on it. That's not even including whatever's in the drawers or sitting on top when it's being moved. And regardless of whether I have the tools up or down, if I have things on top of it, it still raises, lowers, and moves very smoothly. Here is a picture of the original cam used made out of pine. It was 1½ inches thick and 4 inches in diameter. This picture you can see where the bolt went through to attach to the pipe. Unfortunately, after adding the planer and the joiner, the 2 heaviest tools, when I went to move it, the far cam split and it even bent the bolt holding it on. The downside of designing something like this is that I had no clue if it would work until I actually tried it. So in order to make this work, I was going to have to make the cam stronger. I ran to the store and bought some 1x6 oak boards, trimmed them down to 5 inches square, then glued 2 boards together. When I did this, I rotated the boards 90 degrees. This made sure the grain was running in opposite directions so that it wouldn't be able to split as easily. After that, I ordered a 4-inch steel pipe online. I trimmed that down and used that to encase the wooden cam. This way, even if the wood wanted to split, it had nowhere to go because of the pipe being there, or at least this was my thought process behind it. And so far, so good. This also helped ensure the cam stayed perfectly round and would rotate easier. If you would like to do something similar, here's how you would assemble the cam and attach it to the pipe. First, glue the 2 pieces of wood together, rotating the second board 90 degrees for strength. Cut it down into a 4-inch circle and drill the hole ½ inch off center to accept the steel pipe. The further you offset the hole, the higher the bench will rise, but the tougher it will be to do so. With a Forstner bit, cut out a hole on each side to recess the nut and bolt into the cam. Next, drill a hole for the bolt to go through. Make sure this is somewhat tight. The less room this has to move inside, the better, as it will reduce any flex or wear on the bolt over time. Next, drill a hole in the pipe for the bolt to go through. All of the drilling up to this point should be done on a drill press if possible to ensure they are straight and lined up properly. Place a nut inside the bottom of the cam. Insert the bolt into the top of the cam, then fastening it to the nut on the opposite side. Neither the bolt head nor the nut should be sticking out at this point. Slide the 4-inch steel pipe over the cam. Next, drill a small screw hole into the pipe. Then countersink it. Then attach a small screw to ensure the sleeve doesn't slide off during use over time. Make sure the screw is flush with the cam so it doesn't get caught. I chose not to add any glue or adhesive to keep the sleeve in place, in case I needed to remove it to work on the cam at some point down the road. The second most common question I get is about how the flip top functions. It's a little different than most, as I had a lot of tools really close together, so I had to get creative to make it work for this setup. Majority of other flip tops have a stationary pipe that the top spins in place to bring the tool up, or even swap tools if there's 2 attached. Most of them lock or unlock with either a set of latches, or quite a few I've seen use eye hooks that are tightened on the sides using hand screws at all four corners. I didn't like these options because first, I wouldn't have the space on the side to lock it, as I would have multiple tools right up against each other. And second, I didn't want the hassle of having to unlock 4 knobs, rotate the top, and then tighten the 4 knobs back down. The only real drawback to this flip-top design is that it only swings 180 degrees because of the back support. And because of this, you would not be able to have a tool on the top and the bottom. This design will only work if you want to have an empty top surface above and a tool mounted below. So with that said, here are the main reasons I chose to design mine the way that I did. First off, it's very secure. People have asked how solid it is from the video that I previously posted a few years back. The reason it's so stable is because it's supported in 3 spots, so as long as the door is closed, it has nowhere to go. Neither the front nor the back can move down because of the supports that are there, and the bar in the middle adds for extra strength as well. Even when the tools were down, I needed to make sure this was still secure so that when I moved the bench, I didn't have any tools rocking around underneath. Second, there's no extra pieces you set aside, and there's no parts to remove temporarily that could get lost. A lot of the other flip-tops I've seen have either pins or bolts that lock it in place, and I didn't like that concept. I've also seen where you remove the top or the front out of the way and have to set it aside. Again, I didn't want anything else lying around. I wanted everything attached to make it as easy and clean as possible. Third, it's a good look. The doors keep the tools tucked away. As I lean against the bench to work on it, I'm not leaning through or hitting my knees on the tools underneath, and I don't have to worry about any parts falling in there if I drop them. And finally, it's much faster. Most videos I've seen on a flip-top take between 15 and 30 seconds to get the next tool set up and ready. This one takes about a third of the time, somewhere between 5 to 10 seconds because you don't have so many steps. Loosening and tightening 4 hand screws is replaced by opening and closing a door. So just how fast is it? That was shot at normal speed. I wasn't even trying to rush, and I actually got held up when switching hands on the door, so it could even be faster than that. Next is a detailed view of how the flip-top functions and how it's assembled. This is the main base. Overall, really simple, just 3 pieces of plywood put together. One thing to take note on is to make sure you put pocket holes at the top, as this is how the top of the bench is actually attached later on. On my bench, I use an extra layer of 3/4 inch plywood on the top here that isn't pictured, and overall I realized isn't necessary looking back. I could have just cut the base wall 3/4 inch higher and saved myself a ton of time. These 1/4 inch plywood spacers are next, as we need the overall thickness of this section to be 1 inch total to be just a little thicker than the bar we're going to use. Next will be the back support piece that is 3/4 inch thick and will help lock the flip top in place. I cut a slight bevel on the top and bottom of this piece to make it easier for the flip top to slide in and out. It's important that the back support spans across not only the back, but also over both sides as well, so it doesn't sag or bend down over time from the weight of the top. Next are the pieces that help contain the sliding function of the flip top. Notice the front does not come all the way to the front edge on this layer, as that's where the front support on the door will rest. It's important that the bottom spacers do come out, however, as that will help wedge the front door support in and keep the top from moving at all. Next, I use a thin aluminum plate for the bar to rest on. This will help eliminate wear on the wood and possibly eroding down over time. It also allowed me to add a small amount of grease here before assembling so the bar slides even easier. Now let's move on to the top. This will be the bottom piece, and the tool will mount to the underside of this through the mounting holes pictured. This will obviously vary by tool. Next, we'll add the steel pipe. This is what the entire top will rotate on. Now we have another spacer layer with cutouts around where the tool will attach. Next will be a 3/4 inch plywood layer that hugs tightly against the pipe on both sides. To eliminate any rotation of the pipe, I used Gorilla Glue, as it swells up and fills up any gaps around the bar, as I did not want this to move at all, but I'm sure epoxy would work just as well. Next will be the top layer. This is attached from the underside with screws. Once that is done, you can lower the top into the base and slide it back. The door can now be attached, and as it closes, it will lock the top in place. Here is a final view of how the flip top works. The reason this is so sturdy again is because it's supported on 3 points as pictured here. Applying pressure to the front or back won't move because of the supports. Right or left won't move because of the bar. In fact, in 3 years I've never had any issue with any of the tools shifting on me whatsoever.
It is very important that the front support rests on both sides of the base when in this position, as it will help keep them from sagging over time. This also holds true for the front trim piece. If these two pieces are not resting on the sides, it puts all of the tension on the door hinges, which wouldn't hold up and allows the chance for it to sag and move. Another important thing is that if you plan to have the tools as close together as I did side to side, you need to add a chamfer to the doors. The reason for this is so that the door can open far enough and the top support that's attached can get out of the way of the platform rotating with the tool. This is also important to think about when picking out what hinges you want to use for the doors.
The next thing we're going to talk about is the storage within the bench itself. There's nothing really unique about the drawers. However, I do wish that I would have put a cover over the top drawer from the beginning. When the tools flip upside down, a lot of the sawdust can still fall out, not only into the drawer, but also then get into the drawer slides, mixing in with the grease, making them a lot harder to open over time.
This first section is kind of a free-for-all. I wanted to leave it open in case I ever needed to work on the cams or casters, so I didn't want to fill it with anything permanent. In here I have my nail guns, my clamps for the clamp track, and my bench cookies for sanding. The top drawer I use for my bandsaw accessories, like my miter gauge, my fence, and any extra bandsaw blades I have. The bottom drawer have the guards for the bench grinder. Unfortunately, when designing the bench, I wasn't smart enough to measure this tool with them already on there, so I have to take them on and off each time. Under the sander I have extra sanding belts, the table, and a cleaning stick. This small space was a tricky area to fill. For now I'm using it for sandpaper storage, but it's already overflowing. On the other side I have the same thing, and I have no clue what else to do with this space, so if you have any ideas, please leave them in the comments below for me. These drawers I use for my joiner fence, as well as any dust collection adapters and hoses that I use with the benchtop tools. I measured this one when the wooden cam was broken and not on the pipe. Unfortunately, when you already order your drawer slides and have the drawers built, and then realize that, you end up with this monstrosity. And finally, this drawer holds all my different size sanding drums and discs, along with the drill press vise and extra drill press table inserts.
Next is the assembly table. The one drawback to having the flip tops surround the bench is that there's no open gaps, there's no overhangs for clamping, so I had to find another solution to make this work.
This is where the Craig track and the vise came in. These clamps are great because they auto adjust to different thicknesses, which makes it super easy to swap between pieces I need to work on. These clamps are especially great when working with pocket holes. And the top has plenty of room to assemble larger projects. I had originally planned on using bench dogs at some point, but with the Craig track being at 90 degrees and the ability to clamp a board down and use the vise to surface or edge plane shorter boards if needed, I haven't really had a reason to yet.
Next is going to be the rosin and craft paper. Again, nothing too extreme, nothing too crazy. However, it could save you some time and some hassle on your next project.
This paper storage is super simple. The hardest part was finding a roll-on line that fit the dimensions that I needed. I have craft paper currently shown, but I would recommend rosin paper as it will stick less to projects during glue-ups. All I used to mount it was a steel rod going through the roll that inserts into these two boards on the outside. I put an extra hole on each corner to make it easier to get out, and there are magnets on the edge that keep the door closed. Finally, on the inside face, I put a washer on each side to make sure the paper doesn't rub on the side boards. And that's it. Very simple, but it can be really handy to have when you're doing glue-ups or staining.
The last feature I wanted was for it to be an outfeed table. I wasn't worried about miter slots as I don't use them that often, and with both my table saw and my bench being mobile, it would be a pain to line up, so I didn't want to mess with that either.
I made my bench a 1/4 inch lower than the table saw because I use a 3/8 piece of hardboard over the top when I'm using it for an outfeed table. I do this because it gives me a perfectly smooth surface. Even as careful as I was, because there's so many cutouts on the top of the flip top, there's still spots for a board to easily catch on. This was the last thing I wanted because you're going to get burn marks and increase your chance of kickback if the board has nowhere else to go coming off the table saw.
So that's it for the features of the bench. The last thing I want to cover are 5 things I would do differently if I had to build the bench again.
First, I would make it raise a little bit higher off the ground. Because my garage has a drain and the floor slopes a bit, there's a couple of spots where it will bottom out. I put the bottom trim pretty close to the ground as I didn't want anything to roll under it if I dropped it, because then I'd have to move the bench just to retrieve whatever I dropped. So either I would make the bench raise a little higher, or I would just not put the trim quite so low. Second, as awesome as the top looks being all one board and the wood grain lining up, I honestly think I would make the top out of hardboard. I know that at some point I'm going to damage a section, and when I replace it, the grain won't match up and it's going to drive me crazy. It would have been a lot easier to cut out all the pieces for the top if I didn't have to worry about all of the wood grain matching up. Third, I would have loved to have had integrated power in this bench. Because the tops only rotate 180 degrees, it'd be possible to run the power cords through the steel pipe and plug it in underneath. Then you'd only have one master power cord coming out of the bench. The reason I couldn't do this is because I would have had to space the tools out further, as some of the pipes are right up against each other from the tools next to it. To make this possible, I would likely have to sacrifice the paper dispenser. I know it was one of the features and now I'm trashing it, but I think the convenience of having the tools always plugged in and not messing around with the overhead power or moving it from each tool outweigh the benefits of the paper dispenser. Fourth, I wouldn't have wasted time edge framing the doors. At the time, I hated the look of exposed plywood edges, and I especially didn't like the look of it when it was cut at an angle. This is a workbench. It's gonna get beat up. It doesn't need to look like a fine piece of furniture. It took a long time to do and a lot of wood to do it, and honestly it was a big waste of time and money, and going back I wouldn't have bothered with it because it adds zero functionality. And finally, I would have measured all the tools with all of their accessories already attached before making the housing for them. This includes the joiner, the belt sander, and the bench grinder. This was an oversight on my part when I was designing the bench and trying to make everything fit. For example, something as simple as the acrylic shields for the bench grinder. Since I have to put them on and take them off each time, I find myself just throwing on safety glasses instead and then wearing half the shavings on my shirt afterwards.
So that's it. Again, I apologize that I didn't record an actual build video when making this 3 years ago, but hopefully this gives you some ideas and a better understanding of how it functions. So let me know your thoughts in the comment section below. If you enjoyed what you saw and you learned something new, go ahead and hit the like button. If you'd like to see more content like this, please subscribe. It would really help me out. I plan on having a few build videos over the next few months of other projects that I've done, so be sure to let me know things you liked, didn't like, what else you'd want to see on this channel, and if you have more questions about this bench itself. I'll leave you with a slideshow of all the pictures I took during this build, so in case you want to make a similar bench, you can reference them as well. So thank you again so much for watching. We'll see you next time.